So we are going to review some information. Statistics is the study of data, right? It's analysis of data. So we're going to have, really quickly, let's talk qualitative data. And qualitative data is made from words, basically. It's qualities, like if I was going to make a graph about student eye color, right? My answer is not a numerical piece of information.
It's kind of a word.
It's a word, right? It's data made of word, qualities. Now, sometimes you assign numerical values, like shoe size.
Oh, yeah.
Would be a number, but it's also a quality, right? So it gets a little muddy. But qualitative data, we aren't going to deal a whole lot with qualitative data. Every once in a while we'll deal with it, but we're really going to be focusing on quantitative data. Which is made from numbers. It's quantities, amounts.
Oh, this is
like percent scored on a test.
Yep.
The qualitative would be the letter grade scored on a test. But the quantitative is the percentage scored. We're going to focus mostly on quantitative data, numbers. Every once in a while we'll talk about qualities. So let's review. The 5-number summary. Because it gives us these 5 values are important values for us to analyze to compare data sets.
Huh. Okay.
The 5-number summary. The first is called the minimum. The first thing we look at when we look at a data set, if we're doing a 5-number summary, the first value we try to find is the minimum. Which I'm putting in quotes. It's not, it's the least, or you guys like to say smallest. It's the least value. Small implies size. We're not talking about the size of the number. We're talking about the value of the number, right? It's the least valuable number.
Not that valuable. 1, 2, 3.
2, 3, 4, 5. If the first value we look at, the first number in a 5-number summary is the minimum, what's the 5th number? Maximum. It's not size-wise biggest, right? But it's the greatest value.
It can also be called the largest.
Yeah, largest. But it's not large, right?
Oh, yeah.
It's valuable.
You can make the
Can you wait till we're done with notes?
But that doesn't mean that it's biggest.
Correct. The number, not the second number, not the 4th number, the middle is the median. Which is the middle value. But what do you have to make sure you do? Put them in order. Let me get that so you can see it. Middle value but we need to put in order. 5 number summary. Minimum is the smallest value, the least value. Maximum is the greatest value, the largest value. Median is the middle value. You have to make sure it's in order. We've got the lower quartile, which is the median below the median.
It would be a bit confusing.
So, in order to find the lower quartile, you have to find the median first of the data. You have to find the middle number. And then, the lower quartile is the median of the lower half. The lower quartile.
Let me guess, the next one's the upper quartile?
You got it.
Makes sense.
And, ooh, the upper quartile is the median above the median. This makes a box plot or a box and whiskers graph.
I like whiskers.
It's a dot, a line, and a line.
I think you lag.
Uh-oh. It'll catch up.
There we go.
All right, you put a dot at the minimum. You put a dot at the maximum. You put a line at the median. You put a line at the lower quartile. And you put a line at the upper quartile. And remember, this is a kind of misleading graph. We talked about it. Because quartile, quart, means what percent?
The upper, the 1/4.
1/4 or 25%. 25% of the data. So your brain wants them all to be equal because they all contain 25% of the data, right? But they're not always going to be equal. Sometimes it's going to look lopsided. And we're going to talk about what happens when that occurs. Familiar? Coming back to you? Okay. So let's talk about other ways of analyzing data. So let's do other data analysis. So sometimes when we're dealing with statistics, when we're dealing with our data, we're going to use some other ways of analyzing. And, you know, we practice these all year long in our bell work. You might be asked to find the mean of data. What's another word for mean? Average.
Average, yeah, average.
There is a trick. People screw up finding the mean or finding the average. And it's very disheartening. But it happens a lot. And the reason it happens is because it's the sum divided by the number of data values.
Number of
It's the sum. What does that mean? Sum.
You add. You add them all up.
Sum is add and get the total. You have to press equal. You have to do number plus 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 equals. You have to find the sum before you divide. You might be asked to find the range. You might be asked to find the range, which is maximum minus the minimum. You might be asked to find the mode.
What mode is this?
It's the value that occurs, happens the most.
So it's like frequency.
Mm-hmm. You might be asked to find the IQR.
Interquartile range.
Interquartile range, which is the upper quartile minus the lower quartile. And the one that my 7th graders need to know about. 8th graders, you're going to have to do it too, but 7th graders, it's a big one. Is the mean absolute deviation.
Mean absolute deviation.
We sometimes call it
Mad. It's mad.
it is mad. Mean absolute deviation. Oops. All right, here we go. There are 3 steps. Step number 1. Find the mean. Or it might ask you, it might say find the mean absolute deviation, and then it might tell you from the median or from the mode, right? So it might tell you right? It might tell you something else. It might say in the directions like find the mean absolute deviation from the median. Or find the mean absolute deviation from the mode. Or find the mean absolute deviation from the lower quartile. So you have to find the mean or whatever it tells you to find. Then you're going to find the absolute value for each data piece away from the mean or whatever they told you to. So if I had a set of data, if I was going to do, the ages of the people in my family,
Oh.
right? So I take everybody's ages, I add them together, and I divide by however many people there are, and let's pretend that the number is 72.
Oh my, what a big family.
Right? So, 72 is the average age. Then I'm going to take every person, and I'm going to say, okay, well, 72 and my sister's 50. So 72 minus 50 is 12. I'm going to write that data down. 22. 22. I'm going to write that number down, right?
Yeah.
And then my uncle's 80. Right? So 80 minus 72, he's 8 away. I'm going to write down all of the data at how far away each data piece is from my answer. And now I'm going to find the mean of the new list of numbers. Now it's always the absolute value. It's always the positive value. So like my uncle was 8 bigger than my average, and my sister was 22 less than. But I'm going to use 22 and I'm going to use 8 in my list of values.
So they're all going to be positive.
And then your mean absolute deviation, the answer, once you find the average of that new list of numbers, the closer that number is to 0, the more clustered your data is. The farther, the bigger the number is, the more spread out. Mean absolute deviation.